students, welcome to another lesson from iCampSA. In this particular lesson, we're gonna be doing a past paper question. This one is for grade 10 and the paper is from KZN. It was written in 2023 November, and the area of focus is the trigonometry and trigonometric function. Let's get into it. Okay, so for question 4.1, given root 3 cosec theta plus 2 is equal to 0 and 90 degrees and theta is found between 90 degrees and 270 degrees. Okay, use a sketch to determine the value of the following without using a calculator. So we have to determine the value of what? Of cos theta. First thing first, let's rearrange what we have there. So we have, this is 4.1. We have root 3 cosec theta plus 2 is equal to 0. Let's take the 2 to the other side. We're gonna have root 3 cosec theta is equal to negative 2. We divide by root 3 on both sides. So we're gonna have cosec being equal to what? Cosec theta being equal to negative 2 over root 3. But we can't work with cosec theta as it is. So what we have to do is to actually change it, because we know that cosec theta is the reciprocal of what? Is the reciprocal of sine theta. So cosec theta is the same as 1 over sine theta. So we know that this is 1 over sine theta, which is equal to negative 2 over root 3, which is equal to negative 2 over root 3. And let's make sine theta the subject, so to make sine theta the subject, you can either do it by cross multiplication or just taking the denominator and making the numerator on both sides. So in other words, sine theta is equal to negative root 3 over 2, and that is our sine theta. Okay, so we know that. What's the next step? Let's actually draw our Cartesian plane. Since we have rearranged that, let's draw our Cartesian plane. Doesn't have to be that long actually. This is our Cartesian plane, and what let's label it. We have 0 degrees, 90 degrees. We have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. And what do we see here? We see that sine theta is actually negative root 3 over 2. Okay, so in which quadrant is sine theta negative 2? In which quadrant is sine theta negative? That is quadrant 3 and quadrant 4, because that is where in quadrant 3 it's tan who is positive, and in quadrant 4 it is cosine who is positive. Okay, and then another rule that we were given, or another condition, is that theta is found between 90 degrees and 270 degrees. Now let's quickly check which quadrants are in between 90 degrees and 270 degrees. It's quadrant 2 and quadrant 3. Okay, and we know that it can't be quadrant 2 because it's positive, and also we have 2 stars in quadrant 3. That is where we have 2 stars. Therefore the terminal arm of this angle theta will be here in quadrant 3. So sorry, in quadrant, yes, that is quadrant 3. This will be our theta from the positive side. That will be our theta. Okay, use a sketch to determine the value of the following. Okay, now that we have a sketch, now that we have a sketch, we have to determine the value of what? Of cos theta. Of cos theta. Okay, so what else do we have here? We have negative root 3 over 2. Negative root 3 over 2. Okay, it's between that sine theta. Okay, so since we have negative root 3 over 2, remember that our sine is what? Sine is opposite over hypotenuse. So we know that the positive value will be the hypotenuse, because the terminal arm, the length of the terminal arm, is always positive. So the positive value will be for the hypotenuse side, and then the negative is actually for the opposite side, of which is this one, the y value, in other words, which is negative root 3, and then here we're gonna have 2, which is the terminal arm. Okay, so in order for us to be able to determine cos theta, what do we need? We need the adjacent side, the value of x, and in order to calculate the adjacent side, we have to use what? We have to use the Pythagoras theorem. So x squared is equal to r squared minus y squared. Okay, what is our r squared? The terminal arm length is 2 minus our y squared is negative root 3 squared. Therefore, x squared is equal to 4 minus negative root 3 squared is going to be a positive 3, so it's minus 3. And then next we introduce a square roots on both sides. Okay, so square root of x squared, we're going to be left with x, and then 4 minus 3 is going to be 1, so square root of 1 is just 1, and that is the answer for x, the adjacent side is just 1. Okay, therefore what is cos theta? Remember that we are looking for cos theta. So cos theta is equal to adjacent over opposite side, the adjacent side over hypotenuse, so it's equal to 1 over 2. That is cos theta is equal to okay, I'm realizing something here. When we're introducing the square root, remember that we're gonna have a positive and a negative root here. So I forgot to actually put that. Let me drop it a little bit down. So whenever you are introducing a square root, you must always account for both the positive and the negative root. So we're going to have two values of x. Is x is equal to 1, x is equal to 1, or x is equal to negative 1. And looking at our arm there, x is to the negative side of x, so the correct answer will be this one of negative 1 and not the other one. So here we're gonna actually have cos is equal to negative 1 over 2. Cos theta is equal to negative 1 over 2, because it wouldn't make sense to have a positive 1 on this side, because x is negative to the left of x is positive in the second and the third quadrant, so that is what I'm trying to convey to you. So this is the value of x that we have there. Of course, theta is negative 1 over 2. Okay, that was 4 marks. Okay, it's a bit of work. And then next we have to evaluate again without using a calculator. What now? Sine theta times tan theta over cos theta. Okay, let me see something here. I think that's other page, because it's a bit of work. Also this one, it's a bit of work. Okay, now we have added a page. Copy, for 1.2. We're gonna come paste here, drop. We're only interested in that 1.2, sorry, that Roman figure 2 there. Okay, yes, that is 4.1.1 number 2, and we have to evaluate sine theta multiplied by tan theta over cos theta. Okay, what is sine theta? Sine theta is opposite side over the hypotenuse side. So we already calculated sine theta and we find it to be negative root 3 over 2. So we're gonna have negative root 3 over 2 negative root 3 over 2 multiplied by tan theta, which is opposite over the adjacent. The opposite side is what? Is negative root 3, and the adjacent side is negative 1. So we're going to have a negative root 3 over a negative 1. Okay, all over cos theta. What is cos theta? Is negative 1 over 2. It's a negative half. Okay, so this is gonna be equal to negative root 3. Let's put it back as it is, negative root 3 over 2 multiplied by negative root 3 over negative 1 is just gonna be a positive root 3. Okay, all of this divided by negative 1 over 2, negative 1 over 2. Okay, let's start by working the numerator. Negative root 3 over 2 multiplied by positive root 3 is just gonna be a negative 3 over 2, a negative 3 over 2, because the square root multiplied by a square root, remember this rule here is what I'm trying to say. Square root of a multiplied by square root of a is equal to a, it's just that one square root is negative in this case. So we're gonna get a negative 3 over 2. So this is gonna be a negative 3 over 2, negative 3 over 2 divided by a negative 1 over 2. Okay, let's change the division sign into a multiplication sign. So we're gonna have a negative 3 over 2. We can remove brackets at this point. A negative 3 over 2 multiplied by a negative 2 over 1. Negative and a negative will cancel out and will give us a positive. So negative 3 over 2 multiplied by negative 2 over 1 is simply going to be a positive 3. A positive 3. And that will be your answer there. Okay. That was number 2 for 4.1.1. Okay. Let's go ahead and do now. It's 4.1.2. Okay, 4.1.2. Let's actually drop this one, since we have already done 4.2. 4.1.1 number 2. Okay, so we are here in 4.1.2. If theta is equal to 25 degrees and alpha is equal to 38 degrees, determine the value of cos 2 alpha minus theta correct to one decimal place. Okay, once they tell you correct to some decimal place, I always know that you're gonna have to use your calculator on those ones. Okay, so now let's go to 4.1.2. Theta is 25 degrees. We have to determine the value of cos 2 alpha minus theta. Okay, this is equal to cos into 2, what is alpha, multiplied by 38 degrees minus what is theta is 25 degrees. We work what is inside the bracket. Cos of 2 multiplied by 38 is gonna be 76 minus 25 degrees. 76 minus 25 is gonna be 51. This is gonna be cos of 51 degrees. You punch this in your calculator. Cos 51 is gonna be to one decimal place 0.6, and it makes sense for the ratio of cos 51 to be positive, because 51 is in which quadrant? 51 is in first quadrant, and all trigonometric ratios are positive in first quadrant. So always try to make sense of what you are dealing with, and to make sense of the answer you are getting. If you are dealing with an angle that's above 90 degrees, and you are looking at the trigonometric ratio. Say here you had cos 98. Cos 98 falls into second quadrant. It falls into second quadrant here. Okay, so for cos 98 to be positive, it wouldn't make sense, because only sine is positive in second quadrant. Remember your cast method. Only sine is positive in that quadrant, in second quadrant. Okay, so I just wanted to take a little bit of a shortcut there. And then for 4.2, we have to simplify the following expression without using a calculator. 4.2. Okay, I might have to add a page for this one. 4.2. So once they tell you to simplify an expression without using a calculator, just know that you're gonna have to use your special angles. So we have cosec squared 60 degrees plus tan squared 45 degrees plus sec 60 degrees plus sec 60 degrees. Okay, let me add a page here. Where are we? We are here. Okay, so we have to use special angles. Remember the two triangles that we utilize for the special angles. Let's quickly draw them. Since they will assist us in actually solving for this question. The first special triangle is what? Is the one with 45 degrees angles, 90 here, and then these two sides are just 1 unit. You solve for the third side using the Pythagoras theorem, and you're gonna get root 2. And then the second triangle is the equilateral triangle. So equilateral triangle has equal angles. So we have 60 degrees here, 60 degrees. But before we draw the 60 degrees there, we have to put a line that bisects, and it's perpendicular to the dead side. So once it is perpendicular to the dead side from one corner of the triangle, it bisects this line. So this line, therefore, and it also bisects the angle there. So instead of 60 degrees, we're gonna have 30 degrees here and 30 degrees, which makes up 30 degrees. So all three angles are 60 degrees. Since this is a equilateral triangle, let's only put 190 degrees there to show. Yeah, okay. So once we are here, and then this equilateral triangle has all sides are equal to 2 units. So we have 2 units here. Let's use a different color. We have 2 units, and then also the dead side, but we're gonna split it. Since it's already bisected, we're gonna split the dead side. Just 1 unit. 1 plus 1 is what? Is 2. Okay, let's call this middle line what? Line AB. And we have to calculate now the dead side. Remember that this once we have splitted, or once we have bisected this equilateral triangle like this, we now have 2 right angles, because that line AB is perpendicular to the dead side. Okay, well, let's the next step is to actually calculate side that side of line AB, and we're gonna use what? The Pythagoras theorem. So AB squared is equal to since it's not the hypotenuse, is equal to the hypotenuse side, which is 2 squared, minus the other side, which is 1 squared. Therefore AB squared, what is 2 squared? 2 squared is 4 minus 1 squared is 3. So AB squared is equal to 4 minus 1, of which we have just said is 3. Okay, that means AB squared is equal to what? Is equal to 3. And then we introduce a square root on both sides. square roots on both sides. Therefore AB, let me put it here, therefore AB is what? Therefore AB is equal to root 3 units. Root 3 units. Okay, and that AB is that dead side there, is that dead side, which is what? Which is root 3. Okay, then once we have that, we can actually simplify our expression now. We can simplify our expression of which was asked of us. Okay, so let me quickly write it down again. We have cosec squared. We have cosec squared, cosec 60 degrees squared plus tan 45 degrees squared, tan 45 tan squared 45 degrees plus sec 60 degrees. Okay, so we can't work with some of these trigonometric ratios while they're in reciprocals form. We have to change them to the angles we are used to. Okay, first thing first, what's the reciprocal of cosec? It is sine. It is sine. So here we're gonna have 1 over sine 1 over sine 60, 1 over sine 60, and then let's just square everything, you know, because it is squared. To have 1 over sine 60 plus tan squared 45 degrees plus sec 60. What is the reciprocal of sec? Is cos, so we're going to have 1 over cos 60 degrees. We're going to have 1 over cos 60 degrees. Okay, once we are here, we can now actually evaluate this by using the special angles. What is sine 60? Sine 60 is what? Sine 60, we come here to our one of our triangle, sine 60, opposite over hypotenuse, so it's root 3. This is the opposite side over 2, the hypotenuse side. Okay, so sine 60 is gonna be 1 divided, let's just put the division sign, divided by root 3 over 2, root 3 over 2, everything squared, root 3 over 2, root 3 over 2, everything squared, plus tan squared 45. What is tan 45? Tan 45 is opposite over adjacent, so it's this side over the adjacent side is 1 over 1, so we're gonna have 1 over 1 squared plus 1 over what is cos 60. Cos 60, this side is gonna be what? It's gonna be adjacent. The side next to the angle 60 is what? Is 1 unit. Is this side here. This is the adjacent side. That's the adjacent side. Okay, so it's gonna be 1 over 2. So we're gonna have 1 over 2, the denominator there. Okay, 1 divided by root 3 over 2. 1 divided by root 3 over 2 is gonna be equal to 2 over root 3. 2 over root 3 squared plus 1 over 1 squared is just 1, plus 1 over 2 is gonna be, what is 1 divided by a half, plus 2. It's gonna be 2, and then let's square what we have in the first term there. 2 squared is gonna be what? 2 squared is 4 over root 3 squared is gonna be 3, plus 1 plus 2 is what? Is 3 plus 3. Okay, once we are here, let's add what we have. We keep one denominator, highest common denominator, so we're gonna have 4. Sorry, we're gonna have 3 as a denominator. 4 plus 1, it goes 3 times into the denominator, so 3 times 3 is gonna be 9. Therefore the answer is, what is 4 plus 9 is 13 over 3. 13 over 3, and that is your final answer. That is your final answer. Okay, hopefully that made sense. Hopefully that made sense. Let's go ahead and now do 4.3. Let's see something. Yeah, that was 4.2. We haven't left anything. Okay, 4.3, solve for theta correct to 2 decimal places. Correct to 2 decimal places. What does that tell us? It tells us we'll have to use a calculator, since we are asked to correct this one to 2 decimal places, or to present the answer in 2 decimal places. So for 4.3, we have 2 tan theta minus 45 degrees is equal to 1. And we are told that theta is found between 0 and 90 degrees. So it's in the first quadrant. Theta. So expect there, yeah, is in the first quadrant. Okay, that is that. So tan theta minus 45 degrees is equal to 1. Let's start solving by dividing by 2 on both sides. 2 on both sides. So we're gonna have this is equal to tan theta minus 45 degrees is equal to 1 over 2, is equal to 1 over 2. Okay, and then once we are here, we take the tan to the other side. Theta minus 45 degrees is equal to tan inverse 1 over 2. Theta minus 45 degrees is equal to, what is tan inverse of 1 over 2? That is 26.57 degrees. It's 26.57 degrees. We take the 45 to the other side. Theta is equal to 26.57 degrees plus 45 degrees. Therefore, theta is equal to, you add that, is equal to 71.57 degrees. And that is your answer there in 2 decimal places. That was our 4.3. Okay, hopefully that made sense. Let's go ahead and do question 5. Question 5, what do we have here? It's some trig functions. Okay, so given f at x is equal to 3 sine x, so the first sinusoidal function has been stretched by a factor of 3, and g at x is equal to 2 cos x plus 1. Okay, sketch on the trig provided the graphs of f for theta. Okay, the domain is from 0 to 360 degrees. Okay, let's go ahead and sketch these graphs. But first thing first, what do we need to do? We need to draw our table. I'll just put it above here. I'll just put it above there. So for our table, 30, 60. Okay, let me see if we can use all of these intervals to the 30 degrees. I usually just use the 90 degrees intervals to plot the graphs, but since we are provided this many data, I'll just use it. How many points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 10, 11. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I will just have 10 spaces for now. I need to make way for space number 11 and 12. Yeah. Okay, so here we'll have our theta values. No, it's given in x. We have our x values, which is 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees, 380 degrees, 360 degrees. And then our first function is the sinusoidal function. We're just going to say y is equal to 3 sine x, 3 sine x, and then the other one is g at x. We're just going to say y is equal to 2 cos x plus 1, 2 cos x plus 1. Let's find the corresponding values. So start with 3 sine 30 is what? Is 3 over 2, 1.5. Okay, 3 sine 60 is 2.6. 3 sine 90 is 3. 120 is 2.6. 150 is 1.5. 180 0 to 10 is negative 1.5. 240 is negative 2.6. 270 is negative 3. 310 is negative 2.6. 330, that was 330 right after 270. Oh, hey, I skipped 300, but it's fine. Let's just do 330 is what? Is 1.5. 330 is 1.5, negative 1.5. So 300 is just gonna be negative 2.6. Okay, we skipped. And then 360 should be 0. Okay, and then from there let's find the points for 2 cos x plus 1. 2 cos of 0. Oh, we even started at 30. I missed a lot of things here. I didn't include what you call this thing 0, and I didn't include 30. Okay, let's start by including 0 first. Let's make space for 0. Didn't recognize that I didn't include it there. So at 0 degrees, start by 3 sine 0 is 0, and then let's go to 2 cos what is 2 cos 0 plus 1 is 3. 2 cos 30 is 2.7. 2 cos 60 is 2. 2 cos 90 is 1. 2 cos 120 is 0. 2 cos 150 is negative 0.7. 2 cos 180 negative 1, 2 cos 210 is negative 0.7, 2 cos 240 should be 0, 2 cos 270 is 1, and then we have 300 is 2, we'll skip that, to 330 is 2.7, and 360 is 3 again. Okay, now we have our points. It's a bit tedious to do all the points, but we are finally done. Let's get to sketching our function. The first one is the one for 3 sine x, where x is 0, y is 0, 30 and 1.5, 30 and 1.5, 60 and 2.6, 60 and 2.6, 2.6 should be there, and then 90 and 3, 90 and 3 here, 120 and 2.6, 120 we'll put it here, and 2.6, 150 is what, 1.5. Oh, 1.5 is actually here, I made a mistake, this is 0.5. okay, and then 180, 0 to 10, negative 1.5 here, 240, negative 2.6, negative 2.6 here, 270, negative 3 here, 300 is the one we skip, but it's also 2.6 here, 330 is 1.5, it's gonna be here, and 360 is 0. There we have our points. We have to join the curve now. Start afresh. It's not as perfect, our curve. Okay, let me see there. I think this one is a bit better. Our points are not as perfect. You get the point. No pun intended. Yeah, that one is a bit better. Let's emphasize our points a bit. Yes. Okay, and that is how our first function is gonna look. Let's sketch the second one, where x is 0, y is 3, and we have 30 and 2.7. Here we have 60 and 2 here. We have 90 and 1 here. 90 and 1 there. 120 and 0. We have 150 and negative 0.7 somewhere there. 180 and negative 1 here, negative 1, 210 and negative 0.27, 240 and 0 here, 240 and 0, we have 270 and 1 there, and we have 300 will be with 2, and then we have 330, 2.7 somewhere there, 360 and 3 there. Let's join our points. Let's join our points. Okay, and that is the second function. Let's label it. This is the one for g at x. G at x is equal to, let's just leave it at that. And then this one is the one for f at x. Okay, there you have your functions. Next, we are asked to write the amplitude of g. The amplitude of g. So the amplitude of g, what is the baseline of g? G ranges between -1 and 3. But we can actually read the amplitude of g from here. That coefficient of x, sort of cos x, of which is 2, gives us our amplitude. And the amplitude is positive. Even if that was -2 cos x, the amplitude was still going to be what? Still going to be 2. So for the amplitude, just going to write it here. Amplitude is equal to 2. Okay, that's why it's 1 mark. Period of f. This is a sine function, sine and a cos function. It takes what? It takes 360 degrees for one cycle to be completed. So the period is going to be what? 360 degrees. So we come here, we put 360 degrees. And then next, 5.3, for which values of x is g at x minus f at x equal to 4. Okay, let's come here. Where x is equal to 0, g at x is what? Is 3 here, and f at x is 0. So 3 minus what? 3 minus 0 is gonna be what? Is gonna be 3. So that is not equal to 4. That is not equal to 4. We can't take all these values since that will be negative. Then let's come this side. Let's see. At -3 here and -3, and g at x is 1 there. So 1 minus -3 is going to give us 4. And x is what there? X is 270 degrees. So there, where x is 270 degrees, g at x minus f at x will be equal to what? Will be equal to 4. Where, so let's come here, where x is equal to 270 degrees. That is where g at x minus f at x will be equal to 4. That is the value that I'm seeing. Let's see if we have another one. 270, 1 minus, yeah, I think that is the only one. Yeah, that is the only one. Okay, let's go with that one. And then next, for which values of x is f at x multiplied by g at x greater or equal to 0? So the way I like to demonstrate this is that so we're actually looking for positive numbers, because the outcome, the products of this f at x and g at x must be positive. So where we have say f at x multiplied by a positive g at x, that would give us a what? A negative. So it will be less than 0. So that won't work. And the positive f at x multiplied by a negative g at x will give us a what? Will give us a negative. That won't work. But a negative multiplied by a negative will give us a what? A positive. And so as a positive multiplied by a positive f at x multiplied by a negative, a positive g at x will be a positive. So that is gonna work. Okay, so we're looking for these scenarios: negative and a negative, positive and a positive, greater or equal to 0. Okay, let's come here. From 0 to 120 degrees. From 0 to 120 degrees. From here to here. Both functions are above 0, above 0. So they are both positive. So from 0 to to 120 degrees, they are both above, so that is gonna work. Positive and a positive will give us a positive. But once we get to 120, g at x goes below, so we have a negative g at x and a positive what, f at x. So a negative and a positive is not gonna work. So from 120 to 180 it's not gonna work. Those values are not gonna be included. And then we get there at 180 degrees. Now f at x is also negative and g at x is also negative. So from there, from 180 all the way to what? All the way to 240, they are both below, they are both negative, so also that is gonna work. But once we get to 240, what happens now? From 240 g at x becomes what? It becomes positive. So we have a positive g at x and a negative what you call this thing, f at x. It's not gonna work up until 360. At 360 the one is 0 and the other one is positive. That is gonna work. Okay, so we have to put this in where this should be equal to some 3 or 4 marks, because we have a lot of intervals. Yes, we have 3 marks. Let's start with the first interval, where x, where are we now? Okay, so first thing first, it's this is, let me just write it here, write it there, 5.3.2. okay, this is our 5.3.2. the first interval we said is where x is greater or equal to 0 but less or equal to 120 degrees. Is where x, that's the first interval, greater or equal to 0 but less or equal to 120 degrees. That's the first interval. Then the second one is from 180 to 240 degrees. Okay, and then the second one, and where x is greater than x is greater or equal to 120, sorry, it's 180. It's 180 as to 240. 180 degrees but less than 240 degrees. Okay, and then the last interval is what? Is where x is equal to 360 degrees, and where x is equal to 360 degrees. And all of those are your answers. So I guess it's 1 mark for each, 1 mark for each, 1 mark for each. Okay, that is 5.3.2. let me remove these. But that is how you approach these questions, and I know most of students leaves a lot of marks here. I don't know why, but see, that is 5.3.2. let's get to question 6. Okay, for question 6, a handyman attempts to reach the roof of a hole with a ladder that is 5 meters in length. Unfortunately, the ladder is too short and a new ladder will be required. Suppose the length of the ladder needed to reach the top as to be double the distance from the foot of the ladder to the wall. Also, the angle between his current ladder to the ground will need to be equal to the angle between the 2 ladders. Okay, so first thing first, calculate the value of theta. That is 6.1. That is 6.1. We are asked to calculate the value of theta. Here, let's come here. We have theta, of which is our unknown, and then we have this distance, which is the ladder, 5 meters. We have the distance, which is the ladder, 5 meters. Okay, and then what else? We have the other So we have two triangles here that we can work with. This one is the first one, the most obvious one. Okay, and then the other one is the one for 2 theta. So, but if we take the big one, we're gonna have two unknowns, which is x and what? X and theta. If we take that big triangle with angle 2 theta, but if we use let's say this side is adjacent, right, to 2 theta and the hypotenuse, so we use cosine, the x and x will cancel, so we just have to use trigonometric ratios. We're gonna have cos of 2 theta, not cos of theta, cos of 2 theta. We're using the bigger triangle, is equal to what? The adjacent side over the hypotenuse. Adjacent is what? Is x over the hypotenuse is what? Is 2x. Is 2x. And look what happens here. The x and x will cancel. We'll be left with 1 over 2. So cos 2 theta is equal to 1 over 2, and then we take the cos to the other side, would be left with 2 theta is equal to cos inverse 1 over 2. Cos inverse 1 over 2. Okay, what is cos inverse? Half. That should be actually 60 degrees. So it's 2 theta is equal to 60 degrees. You divide by 2 on both sides. Theta is equal to 60 degrees divided by 2 is equal to 30 degrees, and that is your theta, 30 degrees. So once we have 30 degrees, we can find the value of x now, of which I think is hence otherwise determine the length. The ladder should be to get to the handyman. The length of the ladder, remember that the length of the ladder to the handyman is what? Is this side here. Don't be confused. This is the length, which is 2x. That is the length. Remember, suppose the length suppose come here, the length needed to reach to the top has to be double the distance from the foot of the ladder to the wall. So it is double the length of x. So the length of the new ladder is what? Is 2x. Is not just x. So but let's start by calculating x. So we have what? We have 30 degrees theta, 5 meters. We can now use that triangle, this one. You remember this triangle? We can use that one to calculate this side x. So we're gonna have what? We're gonna have this is gonna be, let me see, for 6.2, let's take it here. For 6.2 we are looking for the length for the ladder. Let's start by calculating cos theta. Cos theta we know is 30 degrees, is equal to x adjacent side over what? Over 5x. Remember the triangle we are over 5 meters. Over 5 meters. This is the triangle that we are focusing on with angle theta here, length x, and 5 meters, the smaller one. So we're looking to calculate x. Theta we already know is what? Is 30 meters. So x, make x the subject, we're gonna have 5 multiplied by cos of 30 degrees. Cos of 30 degrees, because theta is 30 degrees. Therefore x is equal to 5 multiplied by cos 30. This is equal to 4.33 meters, but this is not your answer. Length of the ladder is 2 times x, so length is equal to 2x. Therefore length is equal to 2 multiplied by 4.33. Therefore the length is what? Is gonna be 8.66. That is the length of the ladder. Is the length of the ladder, which is 8.66 meters. It's then 8.66 meters. Okay, that is 6.2. Okay, and I think this marks the end of today's lesson. It was a bit long. longer than usual, but anyway, it was a good one. And until we meet again, I wish you all good luck and good study.